This is CS50, and this is the start of week 9. And what we thought we'd do today is not only close the chapter on last week's material, where we focused on server-side web programming with PHP and SQL, some database stuff. We'll talk about a bit of security today, and then transition to a client-side programming language known as JavaScript. But first, some redemption. You may recall that on Wednesday, I set out to write a website that took in users' input by an HTML form, that then stored that user input, names, phone numbers, and cell phone carriers in a database. And then I had a little command line script written in PHP that was supposed to iterate over the rows in the database and send out text messages. Despite several attempts, we didn't get that working by the end. So I spent this entire week working on that code to get us past the point where we left off, whereby all I got by the end of Wednesday was this text message from Margot, as I struggled, followed by a text message from another classmate. You got this, David. Followed by this one, wonderfully encouraging. Kept on going, very heartening. I almost got it until then, and that's the note we ended on Wednesday. And then, actually, perhaps my favorite, a moment later, this came in. Damn live stream. So today we fix this with a quick look at what I've done since. So all of this code is available online from last week's 8 Wednesday source code. And you'll see that I went through and actually I cleaned up things a bit. I introduced a couple other features of an SQL database. For instance, rather than just make carrier a varchar, as I think I did on the fly last week, I instead defined it as what's called an enum. And some of you might have seen this as we explored C. Enum is actually a feature of C where you can enumerate a whole bunch of constants and assign them automatic values like 1, 2, 3, 4 without having to hard code numbers. So SQL supports the same, whereby if you have a database field that you only want to take on one of finite values, you can literally specify it as I have done there for 4 popular US cell phone carriers. So I did that, and I made a number of changes as well, the most important of which was to get email working, because recall that this program relied on what's generally called an email to SMS gateway, which is just a fancy way of saying that Verizon and AT&T and other folks support a server whereby if it receives email, it converts it to SMS and sends out a text message to someone's phone. So if I did this correctly, here is a new and improved form that is going to talk to new and improved code, which you can play with online, and it will hopefully make my phone beep in just a moment. So first, I'm going to type in my name. Second, I'm not going to do this time. I'm going to do inspect element. And this is just a little thing so I don't create hours of post-production work as I did last time. There now is my phone number. I'll select Verizon, and here, let's turn on this microphone here and aim this at my phone here. I'm going to click register, which should hopefully put it into the database. Now I'm going to go to the command line program, which recall was called /text, and cross your fingers. Here we go. So, more fun than this. It's fun, of course, if I get into it, but it's more fun, I thought, if we created one of those movie moments where like something really bad has happened in the world and like all the NSA people's cell phones start beeping with text messages alerting them to this fact. So I thought we would try to recreate the same here, whereby not using a database, I instead in advance wrote a program that looks like this. This is an index.php, and I put this code online as well, that apparently just renders form.php using an MVC style paradigm that we talk about in more detail in problem set 7. That form is pretty simple. It's going to submit to a file called here.php via post, and it's apparently going to ask for a name and a phone number, and then via a so-called select menu, it's going to give you at least 4 popular US cell phone carriers, and then allow you to effectively take attendance by clicking here. And here, meanwhile, is going to borrow some of the code from last time, and if you just skim this, you'll see that there's a whole bunch of error checking. But the beauty at the end is that we're not writing to a database today. We're keeping it simple and just sending out, hopefully, a text message via a function I wrote over the past few days called text, which is in functions.php, which is, again, available online. So if you would like to partake in this, we're not going to be storing anything, go to this URL here in real time. Don't submit it just yet, but let's see if we can have one of these movie moments where everyone's cell phone starts beeping, hopefully just once this year, unlike in 2011 where this went horribly awry. And once you go to that address, you should see a super simple form that if you have a name, a cell phone number, and a cell phone carrier that matches the list there, go ahead and fill out the form, but don't hit submit just yet. The form's going to look like this. Go ahead and type in your name, phone number. Oh, someone's going ahead of the curve. It's okay. Okay, everyone's filled out the form. This should work on a phone too if you want. All right, on your marks, get set, go. Hit here. What? No. I swear to God, I tested this multiple times today. You got it? User error, perhaps. Yes, 2. Okay, it worked for 2 out of a few hundred. 3, 4. Okay, that's good. That's good. 4 out of 5 for correctness. How about? All right. So what just happened? So presumably, without seeing your screens, why might it have erred? It's probably just that we were trying to make too many connections to Harvard's mail server all at once from the same IP address. I'm just guessing, since I didn't have the luxury of testing this code with some 300 people in advance. But for now, realize that at least should have gotten the job done this time. All right, so why is this all the more germane to what's going on? Well, first, a quick couple of announcements. So one, if you'd like to join Chang and Nick and others at lunch this Friday, do RSVP at the usual URL there. If you are thinking of concentrating in or doing a secondary in CS, whether you're a sophomore, freshman, or even junior or senior at this point and can still squeeze in the courses, I'll realize that the engineering school is gathering for free Ben & Jerry's ice cream and advice this Wednesday, shortly after class at 4 p.m. in the CS building at Maxwell Dworkin. If this is too fast on the screen, just go to cs50.harvard.edu for a link to the Facebook event where you can see more details. Meanwhile, I thought I would correct one other thing I goofed on Wednesday. Turns out that Mark's ID on Facebook wasn't 3, it was 4. Turns out he had more test accounts than I recall. But what this felt like an opportunity to do is to pull up a URL like this. So it turns out that Facebook has an API, Application Programming Interface, which is a mechanism whereby you can request data programmatically of Facebook and get back machine-readable information, not web pages, but just raw text, something called JavaScript Object Notation. And in fact, if I visit this URL and zoom in, by default, this is Mark's publicly accessible information. And the interesting detail here is just that his ID is indeed number 4, which I realized as soon as I did this. You can do this yourself if you know your Facebook username. If you have one, just type it up top there. And none of this is private. I'm just doing this even in incognito mode, so I'm not even logged in. And you're seeing that I apparently was user number 6,454 on Facebook, which isn't too bad these days. So anyhow, you'll also see additional information there. And the useful aspect of that is that you can write your own software that somehow integrates data like this into your own application. You can empower users to log into your website, not using their own custom username and password, but maybe their Facebook login, and get information even about their friends if they approve such or similar. So know that CS52 has some of its own APIs, one for the course catalog data, some for the HUDs menus in the dining halls, all of the buildings and locations on campus we have an API for as well that you can query similarly and get back textual data that you can integrate into a PHP or JavaScript or even, though less commonly, a C-based final project. Indeed, ahead for the final project are a few milestones. You got an email from us the other day, realized that the proposal is due this coming Monday. It's not necessarily binding, but you do need to receive your teaching fellow's approval before making any changes thereafter. And then ahead are a number of other milestones. So to tease you too with some possibilities, we have a bunch of these Hue light bulbs, and some of you guys now have some of these in your dorm room as well, and they too have an API. So recall those binary bulbs weeks ago that Dan Bradley and Ansel Duff created for us. They used a software interface to this light bulb, which at the moment is plugged into electricity, and then via wireless is connected to a little thing called a bridge down here, like a little router proprietary to this particular device. But it turns out, if I know how to send HTTP messages, as we all now do, I can send a message like this to this light bulb to turn it on or off or do any number of other operations on it. Notice that it's not get, it's not post. There's another one called put, and there's actually a few other such verbs. But notice there's a path there, /API, /new developer, /light, /one, /state. That's apparently just the path that the company Philips decided you have to hit with an HTTP request if you want to change the state of the bulb using HTTP 1.1. Then notice the blank line. And then lastly, what looks like kind of an array of some sorts. This, again, is going to be called JavaScript Object Notation, or JSON. And what you see here is that there's 3 key value pairs. One key is called on, and its value apparently is going to be true. Brightness is 128, which is some kind of int. And then transition time is 0, which is apparently how long it's going to take to turn this thing on. So right now, this light bulb is off. But if I do exactly this, let me go to a little cheat sheet that Dan set up in advance. And I'm going to go ahead and copy the following command. Curl, as some of you might have gleaned on CS50 Discuss, is a utility like telnet, such that you can simulate HTTP requests, specifically puts. I can send this D data, specifically what we just saw a moment ago, specifically to this URL over here. And then curl is going to handle all of the requisite headers and parsing thereof. So all I have to do is copy this into a terminal window and then hit enter, and the light bulb goes on. And this is all going through my computer wirelessly, somehow down to the bridge, which is then talking to this light bulb. I can do something else. I can make this thing go red, for instance. I can, for instance, make this thing go green. I can make it go blue. And notice in each of these instances, all that I'm changing is the so-called hue value to actually give it some color. So let me paste this one in as well. Now it's blue, and you can do even fancier things where let's go to green. And I could do this, of course, with my own code, but even the API itself supports funky operations like this, which will now bother us for the next 30 seconds. So that's one taste of what you might do with an API, this one involving light bulbs. No, CS50 has a couple pairs of Google Glass if you'd like to tackle something along those lines. Arduino Unos, which are tiny little computers, essentially, on a little circuit board that you can connect wires and other things to and actually control your real-world environment. And then there's a couple of new toys that we have. This one literally just arrived the other day by mail, a Mayo armband. And I thought a way to get you excited about projects that you might use with this hardware would be to play this short clip that they use to tease folks with what that we're now living in the future. So in just a few weeks, you too can be that cool at the CS50 fair. Another device that we have a bunch of that we're happy to loan out for projects is called a Leap Motion Controller. This is a little USB device you connect to a computer that allows you to interact with your laptop, Mac or PC, as though you had like an Xbox Kinect and actually make physical motions, much like we see in this vision of the future. So even if you have no idea how something like that could possibly be invented or work on a hardware level, no matter, right? Even after just a few months of CS50 and an understanding of programming more generally and web programming more recently, and then also APIs and HTTP, you'll have access via software APIs if you do want to borrow one of these devices to actually talk to it and not have to worry about the underlying implementation details, which is completely consistent with this notion of layering and abstraction that we've seen throughout the semester. So also over the weekend, saw a couple pieces of news. Though, first, go to seminars if you would like to learn something more on any number of topics. See the URL there. And this one was sent to me by Chang, who you know, who's been printing our army of elephants. And it was a headline as follows: "I'm terrified of my new TV, why I'm scared to turn this thing on, and you'd be too." So we're now at the point in the semester 2 where even if you have the slightest of understanding of how the web works and HTTP and security, things like this should start to catch your eye, but also you'll understand whether these things are or are not actual threats. So I took a few excerpts from this article here, and the story is as follows. "I'm now the owner of a new smart TV, which promises to deliver streaming multimedia content, games, apps, social media, and internet browsing. Oh, and TV too. The only problem is that I'm now afraid to use it," writes the author. "You would be too if you read through the 46-page privacy policy for your TV. The amount of data this thing collects is staggering. It logs where, when, how, and for how long you use the TV. It sets tracking cookies, as we've discussed, and beacons designed to detect when you have viewed particular content or a particular email message, if you want to check email on your TV. It records the apps you use, the websites you visit, and how you interact with content, doing all of that via your smart TV. It also, creepier yet, that's my addition, has a built-in camera with facial recognition. The purpose is to provide gesture control for the TV and enable you to log into a personalized account using your face. On the upside, the images are saved on the TV instead of uploaded to a corporate server. On the downside, the internet connection makes the whole TV vulnerable to hackers who have demonstrated the ability to take complete control of the machine. More troubling, as if that wasn't smart enough, is the microphone. The TV boasts a voice recognition feature that allows viewers to control the screen with voice commands. But the service comes with a rather ominous warning. Please be aware that if your spoken words include personal or other sensitive information, that information will be among the data captured and transmitted to a third party. Got that? Don't say personal or sensitive stuff in front of your TV. So this is actually for real, and it's hard not to see if you go to like Best Buy or the like for TVs these days. They're all smart in some way, and they're getting smarter and creepier, and they're simply collecting data in ways that we've talked about and then uploading it via HTTP or some other protocol to some server. So this was a fun article in this online website here, which talked about a particular bug or mistake in code that we can actually tie into last week's discussion. So this headline was as follows. The story goes here. Josh Breckman worked for a company that landed a contract to develop a content management system, or CMS as they're called, for a fairly large government website. Much of the project involved developing a content management system so that employees would be able to build and maintain the ever-changing content for their site. Things went pretty well for a few days after going live, but on day 6, things went not so well. All of the content on the website had completely vanished, and all pages led to the default "please enter content" webpage. Whoops. Josh was called in to investigate and noticed that one particularly troublesome external IP address had gone in and deleted all of the content on the system. The IP address did not belong to some overseas hacker bent on destroying helpful government information. It resolved to googlebot.com, Google's very own web crawling spider. Whoops. After a bit of research and scrambling around to find a non-corrupt backup, Josh found the problem. A user had copied and pasted some content from one page to another, including an edit hyperlink to edit the content on the page. Normally, this wouldn't be an issue, since an outside user would need to enter a name and a password, but the CMS authentication system, the login system, didn't take into account sophisticated hacking techniques of Google's Spider. Whoops. As it turns out, Google Spider doesn't use cookies, which means that it can easily bypass a check for the isLoggedOn cookie set to be false. It also doesn't pay attention to JavaScript, which would normally prompt and redirect users who are not logged in. It does, however, follow every hyperlink on every page it finds, including those with delete page in the title. Whoops. So what does this mean in more technical but fairly accessible terms? It just means that throughout their website, they had URLs not unlike this one that you might see in problem set 7. Recall in problem set 7, or know in problem set 7, that you're challenged, among other things, to sell stocks on behalf of users. But implementing that feature by way of GET via hyperlinks in your user interface, probably not the smartest idea. Because if your site is somehow accessible, either by a human who's clicking around, or by a bot like Google's, or a spider as they're called, that's just crawling the web, trying to index the web as a search engine, they could very easily hit via GET this kind of URL, and that's functionally equivalent to, in this case, selling all shares of Google. Now, frankly, it's completely asinine that the CMS used JavaScript and cookies to implement its login system and not doing that server side as you guys do and will in pset 7. There's a login.php file. Always, 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 security should be done on the server side, not on the client side, because as this article suggests, and you might yourself see at some point, it is trivial for a user, good or bad, to just turn off JavaScript, not to mention cookies. So that is your daily WTF. There's one more, which is just kind of scary, so I'll mention it, if only as a life lesson. Whenever you use an application called like Snapchat or the like that says these photos only last for 5 seconds, 10 seconds, or whatnot, they're ephemeral, that is absolutely not the case. Like, there is no way digitally to implement some form of video or image or textual sharing such that a recipient on the other end can't somehow save the data, right? In the most naive way, someone could take their phone and they have a 10-second window while looking at some snap to just take some other phone and photograph it, obviously, so you can preserve something digitally that way. Some of you know how to take screenshots on your phone. In fact, if you don't know this, realize that at least Snapchat and I think other applications these days at least tell you if the recipient has actually taken a screenshot of your image. But worse yet, this was the snappening, as someone coined it recently, where some 100,000 snaps had been released in what's called a torrent file on various websites, ultimately. And these contained a whole bunch of private messages and posts. And it turns out most of them benign, so not what you might expect. But because people had used a third-party website, logging in with their Snapchat username and password, and then saving all of their snaps on this third-party website. And it was that third-party website that was hacked, which just meant someone figured out how to get all 100,000 plus of those images into their own hard drive for subsequent sharing. Frankly, here too, it's sort of asinine that Snapchat is implemented in such a way that a third party can sort of intercept the data and that it's not tied to your own application running on the phone. But here too, realize that these things should not catch you by surprise, or at least there should be a life lesson in here. If you'd like the technical details, go to that URL there that's in today's slides. All right, any questions on today's life lessons in CS? Turn that off. Anything at all. Anything at all. A lot of people checking their Snapchat or something now. All right, so SQL, structured query language. Let's wrap this up, and also, even though we're just scratching the surface of this language, we'll give you enough of the language in the form of pset 7 so that you can tackle some fairly common functionality. But realize there's a couple things we don't require of you, but they're going to be important come final projects, and certainly come making actual websites with actual users, is this design decision. It turns out that in a MySQL database, you have bunches of choices, like the data types for your columns and other things, but you also have the choice of a so-called storage engine for all of your data, the sort of file system, if you're familiar, for all of your data. What format is it ultimately stored in? And the most common, perhaps, has been MyISAM and InnoDB, technical terms that we'll care about only to the extent that one has and one doesn't have the following feature. Suppose that you have a little dorm fridge, and suppose that you and your roommate who share this fridge are really fond of, say, milk. And this is, in fact, how the story was told to me way back in the day when I took a course called CS161, Operating Systems, which similarly explores this topic. So you've got this fridge, you're out of milk, and you come home, your roommate's still at class or whatever, and you decide, I'm going to go out and get some milk. So you close the fridge, lock up the dorm room, go across the street to CVS or wherever, and get in line to buy some milk. Meanwhile, your roommate gets home from class, gets into the dorm room, opens the fridge, also realizes, ooh, we're out of milk, so he or she closes the fridge and then happens to go to the other CVS, which happens to be 1 block away from the other CVS in the square, and gets in line there to get some milk. Now, of course, a few minutes later, you both get back, and the worst of all possible outcomes has happened. Both of you have milk, and you don't really like milk that much, so one of them is just going to sour at some point. So now you have excessive amount of milk in the fridge, all because why? Yeah, you didn't somehow communicate with each other that you were getting milk. So in the simplest of ways in the human world, how might you avoid this silly scenario from happening, such that you only end up with one? Text them. Yes, good. But how else? A Post-it note, right? Any form of communication that tells your roommate, don't go into the fridge for milk, I'm going to go restock on my own. So you somehow need to lock this resource. So we can make this, we can kind of ruin the story and turn it into a CS story, whereby think of this as just like a variable, which is storing some value. And right now the value of milk is 0, but you don't want your roommate to inspect that variable and then make a decision, him or herself, based on the state of that variable if you're in the process of changing the state of that variable. So one of the lines of SQL that we give you in pset7 specification is this one here. And we don't spend a huge amount of time talking about it, but it turns out if you are trying to buy some stock in CS50 Finance that you already have some shares of, you want to be able to do a number of things instantly together. You want to be able to effectively, on a high level, check, all right, if I want to buy more shares of free, the penny stock we talk about in the spec, all right, I want to first check how many shares I have, and suppose it's 5, and suppose I want to buy 10 more, I ultimately want to have 15 shares of stock. So I have to ask 2 questions. What's the state of the variable? What's the state of the row? How many shares do I currently have? Then you want to go ahead and update it. So that's the analog to the milk in that you check the row, and then you want to update it, because if you want to buy 10 shares, you don't want to change the row to 10. You want to change it to 5 plus 10, or of course 15. This line of code ensures that those 2 conceptual ideas happen together, or not at all. No one, including some other user who's logged into the same website, can somehow interrupt the checking of the row and the updating of the row, the select and the update, if you will. And the syntax isn't super obvious, but this one line, long as it is, ensures that those 2 operations, check the variable or check the row and update the row, happen atomically. Oh, here we go again. Text message on my phone. So let's make this a little more concrete. Suppose that you're not implementing a refrigerator and you're not implementing pset7, but an actual bank or an ATM, an automated teller machine, whereby you somehow want to be able to empower users to transfer money from one account to another. OK, I'm going to mute this now. Thank you. So we want to move money from one account number into a different account number, specifically $100. So this is kind of an arbitrary example whereby you, the ATM, might want to execute 2 SQL queries, subtract from one account and add to the other account, but you want to ensure that these 2 lines both happen or not at all. You don't want something getting interrupted. You don't want some smart bad guy somehow standing at Bank of America with 2 ATMs in front of him and somehow sort of typing in the commands at the same time, hopefully trying to deduct $200 instead of $100 and only having $100 credited. In short, you want this to behave exactly as you expect. And the way you do this in a SQL database is you wrap it in what's called a transaction. Literally in SQL, you can call CS50's query function with quote-unquote start transaction. Then you can execute any number of subsequent SQL queries, but none of them take effect on the database until you call query quote-unquote commit, if again using PHP. And in this way, you can ensure that even if you have 1,000 users all hitting your database at the same time, SQL will promise that these 2 queries will be implemented one right after the other. So you don't end up with excessive milk or the wrong amount ultimately of money. So keep this in mind, not so much for pset7, but for final projects, if you're actually trying to move data around across tables, as you might here. But perhaps even simpler and more obvious to understand with an example is this one here. And someone emailed us about this just the other day when he saw something similar online. So to my knowledge, the PIN system is not vulnerable to this attack, and I have no idea if it even uses a SQL database underneath the hood. But let's use it as this for the sake of discussion. Here's the screen that Harvard folks tend to see when logging in with their Harvard ID number and their PIN. And suppose that the PIN system were implemented in PHP, and with a MySQL database, the code that someone might have written years ago might look like this. First, declare a variable called username and just get that from the post superglobal. Then get another variable called password and do the same. And then just execute this long query here. Select star from users where username equals such and such, and password equals such and such. Notice that the curly braces I've used here just mean to PHP, go ahead and substitute the value of those two variables right there. They're not strictly necessary, but they tend to avoid subtle syntax errors. So this looks completely correct at first glance, and it is. You could implement the pin system in this way, but suppose that a super smart and malicious student inputted this as his or her pin. So I've removed the bullet signs here in the mock-up, and I've actually revealed what he or she might be typing, and it's a little strange. But what jumps out at you at potentially worrisome about the user's input, even if you have no idea what a SQL injection attack means? Why does this look a little fishy? What's that? The or is a little suspicious. In fact, that's a keyword from SQL, so that doesn't bode well. The fact that there's all these single quotes there, in fact, one of the easiest ways to break some database is by typing in a name like O'Reilly that has an apostrophe in it, because if the human who wrote the code behind the scenes doesn't take into account that there might be single quotes in a user's input, and he or she is using single quotes in their code, bad things can happen. In fact, worse yet, consider this. If this was, again, the code that someone at Harvard years ago wrote for the PIN system, notice what's about to get substituted for username and password if the user types in again, Scroob as their username, and then 1, 2, 3, 4, 5, quote, or quote unquote 1 equals quote 1. And notice what's key here is the user has not started their password or their PIN with a quote, and they haven't ended it with a quote. Because he or she is assuming that if the programmer wasn't so sharp, they are going to have those single quotes in their code. So here's the code, and the substitution that might now happen is this. And I've underlined what the user has typed in, so before, after, and notice what's mildly worrisome now about the right half of this SQL code. It's a little more complex, admittedly, than the queries we've seen, but this can't possibly be a good thing if you're saying select star, which is select everything from the user's table, where username equals Scroob, and password equals 1, 2, 3, 4, 5, or 1 equals 1. Right? What's the logical implication of that last clause, presumably? It's just always true. And because we have sort of guessed or figured out by trial and error that the programmer who wrote this code did not anticipate a human, a bad person, typing in single quotes as well, we can syntactically complete the SQL query with something nonsensical, but something that is syntactically correct that always evaluates to true. So if this code is being used to answer the question true or false, should this user be allowed to pass, the answer is always apparently going to be true, because this is always going to select something from the database, because 1, of course, always equals 1. So what's the solution? Well, in pset 7, we actually avoid this altogether. We give you a query function, and we encourage you to use question marks as placeholders, similar in spirit to printf's %s. But what's key about the question marks here is if you actually read through functions.php, where our query function is implemented, those question marks are escaped, whereby anything potentially dangerous, like a single quote, is turned into an escaped single quote. So this is what's really happening if you use CS50's query function or any number of third-party free libraries that do the same. Doesn't matter in this case, in green, if the user has typed in a single quote, because the query function that we wrote is going to add backslashes before any such dangerous quote. So this is not, in fact, going to be legit. This is like typing in a crazy-looking password that's, of course, not going to be Scroob's actual password. So the takeaway for CS50 is, 1, absolutely always use something like CS50's query function or the underlying library, which happens to be called PDO, but never, never, never do code like this without escaping or scrubbing, as they say, your inputs. And you will, at some point, probably come across some website like this. In fact, it seems to be the case like at airports and hotels and places where they have like free Wi-Fi access that you have to log into. These websites are always horribly implemented. And so a sort of fun at-home exercise, not for malicious purposes, or more of a fun on-the-road exercise, is to just like type an apostrophe, a single quote, into a form on some website and see what happens. And if the server crashes or gives you some kind of error message, it may very well be that someone hasn't anticipated this. And then you should alert the proper authorities and proceed no further. All right. So now you guys should hopefully understand a bit more geek humor here. You know you're a geek. For now, for the next several years, you will remember who Little Bobby Tables is because of this cartoon here. So keep that in mind as we context switch one last time today to JavaScript. We've spent relatively little time on the syntax of PHP because it's actually super similar to C. And nicely enough, JavaScript too is super similar to C's syntax as well, as we'll see in just a moment. And as we'll see later this week in particular, what you can do with this language, though, is all the more powerful, especially with APIs. But first, a quick tour. So one, in JavaScript, there's no main function, which is nice, as is with PHP. You can just write code. Conditions look like this, and Boolean expressions might look like this or like this. Switches exist, and they might look like this. For loops look like this. While loops look like this. Do whiles look like this. And then arrays look like this, very similar to PHP. But notice that in JavaScript, you declare a variable, not with a $sign, not with a data type, but literally by saying var for variable before it. It, too, is loosely typed in that it has types, but you don't explicitly declare them. And then a string, for instance, might look like this, that string being called s in this case. And then an object, and these we'll see more before long. An object is perhaps one of the most commonly seen data structures in a JavaScript-based program because it allows you to associate arbitrary key-value pairs just like PHP's associative arrays and just like your own hash table or trie as we implemented a few weeks back. So let's actually see what we can do with JavaScript. And in particular, this is a laundry list of features that browsers have that allow us to hook JavaScript into a website in the following way. JavaScript is often used as a client-side scripting language. It's not compiled, it too is interpreted. But unlike PHP, which has been running on the server, in the web server or deep inside of the client, JavaScript is different in that it usually runs in the browser. So any JavaScript code you start writing for pset 8 or your final project or in the real world is generally going to be saved on the server, absolutely, in a .html or a .js for JavaScript file. But the browser is going to download that JavaScript code to your own instance of Chrome or IE or Firefox or whatever, and the code is actually going to get executed inside of your own browser. Just to make this more real, let's see this in concrete form. We have no idea what this code does without really reading through it, but let me go to facebook.com without logging in. Let me go to inspect element and go to, let's say, network and reload the page. And we'll see, let me shift reload the page to get all the requests anew. And the very first file I see is CSS. Here's a first JavaScript file. And I have no idea what this does, but here's some of the JavaScript code that drives Facebook. It's not even really that revealing to zoom in. It's still just as nonsensical. But you'll see even down below, there's even more of these JavaScript files. Whoops, that's a ping. Let's go down a little further. There's one, there's one, there's one, there's one, there's one. So even though Facebook behind the scenes is written in part in PHP and Facebook's own version thereof, there's a huge amount of JavaScript. In fact, any of the chatting you do on Facebook, any of the inline timeline updates that happen in real time, all of that is driven by JavaScript. Yeah? They did. So that's why I say a variant of PHP called hip hop that they actually added features to, such that when Mark first implemented Facebook, it was written in PHP, and that sort of has remained the sort of front-end language that they use for much of their coding, but it hasn't been a language that scales particularly well to billions of people, and so they have added their own improvements behind the scenes, and they use any number of other languages for various pieces of their infrastructure. So yes, it's a variant of what we now know as PHP. So let's take a look at a couple of examples of how we might use JavaScript here. In today's source code, we have a bunch of files, the first of which let's call DOM0. So DOM0 looks as follows. Let me go into this directory and open up dom0.html, the top of which has a doc type declaration saying here comes HTML5. And now here's an HTML tag, here's the head tag, and here's what's new today. We now have a script tag inside of the head of the page. And this apparently does very little, but notice that I've defined a script, a JavaScript. And as an aside, since this is a common misconception, JavaScript has absolutely nothing to do with Java, the language that some of you might have learned in APCS. It was more of a marketing thing than anything, riding the coattails of Java years ago. But JavaScript, nothing to do with Java, just similarly and annoyingly, confusingly named. So here is how you declare a function in JavaScript. Literally say function, and then the name of the function, then any arguments it might take, just like in PHP. Turns out in JavaScript, one of the most annoying functions that exist is alert. This is a little window that will pop up and alert you to some piece of information. It's generally frowned upon, but we'll use it as our first exercise here. Notice a few features of JavaScript. Single quotes and double quotes don't actually matter anymore. Single quotes and double quotes can be interchanged, whereas in C, you have to use double quotes for strings, and you have to use single quotes for chars. In the JavaScript world, most people use single quotes around strings just because it's a stylistic thing. But what's the plus operator here, which we haven't seen before? Yeah. Concatenation. So C does not even have this. PHP has the dot operator, which does this. JavaScript has the plus operator, which confusingly is just like Java. Now, what's going on here? So here's where a basic understanding of that picture we threw up a couple days ago comes into play. Remember when we had a simple version of an HTML page, just said hello world, and then we drew a tree to the right, which had a bunch of rectangles and lines connecting them like a family tree. So that's the so-called DOM, or document object model, and it turns out that you can access rectangles in that tree with syntax like the following. You literally say document, which is a special global variable in a JavaScript program, that has a function associated with it that you can access similar to a struct, but you simply say dot, and then the function's name, get element by ID. The element I want to get is apparently quote-unquote name, and then I want to get its value. Now, we're getting ahead of ourselves. I'm not even sure what all this is about. Let's fast forward to the HTML on the page, which is super simple. Notice that I've defined a form down here. Notice I've given it a unique ID, even though we've not used this attribute before, but this exists in HTML. You can uniquely identify some chunk of HTML with an identifier like this. Notice now this. Turns out HTML supports, per that laundry list a moment ago, a whole bunch of event handlers. And this event handler says on submit, on the user's submission of this form, call the following code. And the code that's going to be called or executed is exactly this, the greet function followed by return false. Everything else should be pretty familiar. Here is an input of type text whose ID, in this case, is going to be name. We don't have an actual name attribute this time, and a submit button. So the resulting page looks like this. And the resulting behavior, you'll see, looks like this. The page at localhost says, hello, David. Hardly an aesthetically pleasing way to greet a user, but what's actually going on? Well, consider what this is. This is a text field, and according to the HTML here, I've given it a unique identifier called quote-unquote name. Meanwhile, I've said, when the user submits this form by hitting enter or clicking the submit button, call the function called greet, and then return false. Let's consider those in reverse. Notice when I click submit, the URL of this page does not change. The browser's icon didn't start spinning. I didn't go anywhere, and that's literally because I said return false. Return false short circuits or stops the default behavior of a form. So that then leaves us with this one final question. What does greet do? Well, greet apparently calls a function called alert, passes in one long argument that's the result of concatenating together a bunch of substrings, hello, comma, space, then whatever this returns. So document is like a global variable to that root of that tree, calling a special function, otherwise now known as a method. A function that's inside of a variable is called a method instead of a function. So get element by ID. What element do you want to get by its ID? Quote unquote name, and then specifically value. So in other words, that code simply finds the text field whose ID is name and then gets its value. So if I were to change this and say Davin instead of David and click submit, now we have a greeting for Davin. All right, so all fine and good, but let's see if we can make this a little cleaner, since just writing code like this is generally going to be frowned upon. This is going to look scarier, but what's the first difference that you note here in this version, besides the name changing to DOM1? What structurally looks different about this versus the other? Yeah. Yeah, the form's on top of the script for some curious reason. So that's the first thing that jumps out at me too, and thankfully at least, this part is identical. So the only thing that seems to be different is this. So here's what's neat about JavaScript 2, and it makes it hard to understand at first glance, especially for final projects if you're looking at sample code online, but it boils down to some basic syntactic features. Here again is that global variable document. Here again is that method or function that says get the element by ID. This time I want to get the ID called demo. Where is that? That's apparently right here, the form itself. And now notice that apparently if I get back that node from the tree that represents the form itself, not a text field, it turns out that that form, that node or rectangle from the tree, has what we'll call a property. Very, very, very similar in spirit to a struct in C. It's just a data member inside of this rectangle. So I've got the form here, and I'm attaching, or I'm assigning to its onSubmit handler, or rather, onSubmit property, the following function. And this is by far the craziest thing thus far syntactically. It turns out in JavaScript and in PHP, and frankly, for that matter in C, even though we don't do it, you can have nameless, anonymous, or AKA lambda functions that don't have a name but can be called nonetheless. So what I'm doing here is I'm assigning this onSubmit property, which is inside of this node of my DOM tree, a function pointer, if you will. That function has no name, but that doesn't matter because we'll see in a moment how to call it. When this function is called, this code gets executed, then false is returned, just like before. But notice what I've done. At this point in the story, I have a form. It's got a unique ID called demo. Down here, I have a script tag that executes the following code. It attaches to that node in the tree, to its onSubmit property, this function here, and just by nature of how browsers work, when I now click submit or hit enter, that function is going to get called. It doesn't need a name because who the heck cares what it's called? The only time it's ever going to get called is when I submit the form. There's no need for me, the human developer, to actually call it anywhere else. Now, just as a teaser, as if that weren't mind-bending enough, we can even make this look more cryptic using a super popular library called jQuery. In fact, jQuery and JavaScript are often conflated. And what we'll do on Wednesday is start using this language and these libraries to build increasingly asynchronous and dynamic applications like map-getting applications, applications that update the web page in real time, much like Facebook or GChat did, and no longer confine ourselves to hitting submit via get or just post alone. So we will see you on Wednesday.